Here we have another composite function problem. We're going to find we have f of x equals 12, square root of 12 minus x, and g of x equals x squared minus x. So they want us to find f of g of x. So that's f of x squared minus x. So we're going to put that in place of the x in the square root of 12 minus x. So it's going to be the square root of 12 minus quantity x squared minus x. So it's going to be the square root of 12 minus x squared plus x. So that answer would work. Also the answer square root of 12 plus x minus x squared would work. You could also do negative x squared plus x plus 12. So a variety of answers would work there, obviously. Now, the second part, we're supposed to find the domain. And so for the g, there's no problem. It's a quadratic. Everything's going to work. But once we put it under the radical, now we have things to consider about the radical. That this 12 minus or plus x squared minus, where's my pencil? Let me fix that. My 12 plus x minus x squared needs to be greater than or equal to 0. So when we look at this, it might be helpful to see negative x squared plus x plus 12 is greater than or equal to 0. For me, it helps to see this with a positive leading coefficient, so I'll divide everything by -1. And of course, when I divide by -1, what happens to that sign? It becomes x squared minus x minus 12 is less than or equal to 0. So this could be factored to be x minus 4 times x plus 3 is less than or equal to 0. And so these critical numbers that we're looking at, these zeros here, are going to be x minus 4 equals 0. This is by the zero product property. So x equals 4. And x plus 3 equals 0. So x equals -3. And those are going to be those critical values. Now we want to know the interval, the critical values where it changes. So where is this? I'm looking at this line right here. Where is that parabola going to be going to be less than 0? So a parabola with a leading coefficient now would be opening up. So if here's our axis system, we would have it hitting here and here, and it opens up, so it'll be something like this. So our interval for it to be positive, or to be negative, excuse me, is going to be from, so I'm doing a bracket here, -3 to 4. Another way to have done that same part would be to do a table. And if we went along with the table, we had a 0 at 3 and a 0 at 4, and we had the factors x minus 4 and x plus 3. If you pick a number smaller than -3, like -4, between -3 and positive 4, like 0, and bigger than 4, we'll go with 5. -4 minus 4 is negative. -4 plus 3 is negative, so that's a positive. 0 minus 4 is negative. 0 plus 3 is positive, so that's a negative. 5 minus 4 is a positive. 5 plus 3 is a positive, so that's a positive. We wanted the region where it's less than 0. So again, since we're looking for it being less than 0, this would be what we're after. And again, that corresponds to the -3 to 4 interval. Okay, so I hope that helps.